circle, or 3 circles. Okay. So again, this is the normal stress, and then we have our shearing stress. Okay. 3D Mohr circle is still a circle, eh? It's not a sphere. Okay. Element rotate clockwise, anti-clockwise. So we did specify that this is our stress X line, and then we have our stress Y line, and then our stress Z line. And because the shear is equal to 0, this is our point X, this is our point Y, and this is our point Z. Okay, right? So we will draw the X and Y first. Okay, so this is our X and Y. So this circle that we just drawn, right? This circle that we have just drawn, right? It is for the XY plane. And the XY plane is our in plane, right? Because it has the biggest surface area, right? So this is our XY plane. Over here is your YZ plane. And over here is your XZ plane, right? And this is the in plane. If it's not written, means it's out of plane, right? Right. So this is the in plane. Then I'm going to draw another circle, right? So this circle will be from here to here, right? And this circle over here, right? This circle over here will be for your YZ plane. And it's your out of plane, right? So your in plane, let's do this also. So for your in plane, this is your tau max. Okay. So this is your maximum stress for XY plane. Okay, and then the next one, this is your maximum for your YZ. Now you know why is it YZ, right? Because it touches point Y and point Z when you draw the circle. And we have another circle. Okay, we have a third circle. So the third circle is this circle over here. Okay. So this circle over here is our what? XZ plane. And this is our out of plane. Right? And then now, if we were to draw this, it has the biggest radius, yes or no? So you put over here, right? So this will be your tau max. And is your tau max for your X Z. And this is in fact your maximum shear. Okay. Now, what do you realize? This is critical, right? Now, why 3D is critical. I think this is a very good example why 3D. Now, if you were to ignore 3D, okay, you say, Eugene, you know what, buddy, stress Z is equal to 0. I can do a 2D Mohr circle. You can solve it. I'll tell you where's the problem. So if we just analyze this problem with a 2D Mohr circle, right? So this is your stress X, and this is your stress Y. And you say, I'm going to ignore my Z because it is 0, right? So if we were to do that, right, this value over here will be your stress max for 2D analysis or 2D Mohr circle. Yes or no? Right? And then you code that value, and then when you load your structure, crap, it failed. Why? Because the maximum shear is where? The maximum shear is your what? Shear in your XZ, which is rightfully the shear at the what? Out of plane. Yes or no? Right? In 2D, the in plane is what you draw. This is always your in plane. Right? You ignore the rest of the plane. But if you do 3D analysis, you realize that the tau max is in fact what? Out of plane. So either your structure will fail, or you underestimate your what? You underestimate your maximum stress, shearing stress acting on the structure. Okay, then you say, Eugene, you know what? We'll be fine. We just put a safety factor of 2. No, does not go this way. Does not work this way. Okay, so that is why this is a good example of why 3D Mohr circle is important. Okay, but listen, in the right condition, the in plane can be the maximum shearing stress. Okay, now let me finish this first. Okay, so for condition number 1, by looking at this condition over here, right, we can say that the tau max, right, is equal to the tau max in the XZ plane, or is equal to tau max in the ZX plane. Okay, so to find the tau max over here, right, is basically is equal to stress X divided by 2. Okay, and we know that the tau max is out of plane. Okay, we know that tau max is L. Okay. So if we call stress max is equal to stress X, and stress mean is equal to stress Z, which is equal to 0. For this condition over here, tau max is equal to stress max divided by 2 when stress X is greater than stress Y, comma, both are positive, and stress Z is equal to 0. Okay, then this condition is what? It's true. Okay, now let's look at another condition. Okay, let's look at another condition. So the next condition that I'm going to draw, okay, next condition, do the same, X, Y, and Z. Okay, now for the next one is where stress X is positive, stress Y, oh, I have to write condition number 2. Where you have stress X is positive, stress Y is negative, stress Z is still equal to what? 0. Okay, so I'm just going to copy this, and I'm just going to wipe things away. Okay. Okay, so stress y is still the same. So stress x is it. Now stress y is what? Compression. Okay, now stress y is in a compression mode. Okay, so now let's draw Mohr circle. Okay, let's draw 3D Mohr circle. So this is our stress, normal stress. Okay, so that is our normal stress. Then we have our shearing stress. Element rotate clockwise. Element rotate anti-clockwise. Okay. Then we have our stress X is positive, right? Stress Z is 0, right? Then we have stress Y is in compression. So because they have 0 shear, this is our point X, this is our point Z, and this is our point Y. So let's do our standard XY like 2D Mohr circle. Okay, so we draw our XY plane. Okay, so this is our XY plane, and this is our in plane. Then again, I want to highlight the in plane. Right, so relative to our 0 line over here in normal stress. Right, this is our tau max XY. Okay, then we are going to draw our YZ. Okay, we're going to draw our YZ. Okay, so the next circle. Right, so this is our YZ plane. So this is our out of plane, right? And then the distance from here to here, right? This is our tau max YZ. Okay, and then finally the third circle. It's over here. Okay, so this is our XZ plane, and this is our out of plane, right? So for this case, this distance from here to here, yeah, we'll straighten this out. So the distance from here to here, this is your tau max in the XZ plane. So what you realize now, for this case, the shear in the XY plane, which is your is going to be your what? Tau max. And this case, this is in plane. Okay. So if you have a condition like this, it is okay to use what? 2D Mohr circle. Yes or no? Right? Because if you were